All right, the quiz is now available on Quarkus, I think. If it's not, let me know. So again, kind of the quiz is going to be a few minutes at the beginning of lecture. So now, complaints about it's not being there? Yeah, okay. So again, as promised, 99% of the points are for doing the quiz. 1% of points is for the correct answers. I will, however, tell you what the correct answers are. You can potentially fix your answers if you like. It's all fine. It's just there to keep you on track. With that said, please take it seriously. So especially take it seriously if you see that you cannot solve something, and then, you know. All right, so let's take 3 minutes or something, or let's say until 4:15. So people who are late, please do the quiz. So until 4:15. If you're on the YouTube stream, please do the quiz. All right. We're still working on the quiz. All right. Let's take, I think kind of not most people, but one more minute, or like I guess 20 more seconds. Oh, there's a quiz. Go on Quarkus, do the quiz. All right, so let's take a look. What's going on here? So again, kind of two ways that I'm doing it. I kind of eyeball it and try to figure it out, and I probably can. The other way to do it is line by line. So eyeballing, what's going on? Change A is setting A to be 20, but it never says global A. So that means that A is scratch work, despite the name of the function, right? So right away, that tells me that if I print A over here, that's going to be 12. So change A also has a side effect, right? So change A says print A. So what is the A that gets printed? Well, nothing weird is going on. You're saying A equals 20, print A, that is going to print 20. So let's also do it line by line. So I'm copying and pasting it. So run it. So that's just kind of, so this is just like the copy paste thing. So what I'm going to do is select Shift Tab so that it's unindented, and then I tab again so that it's indented. The problem was the indentation when I copied and pasted from Quarkus that got messed up. There is like an invalid character on line 12. I think this is like, yeah, this is like the copy and paste from Quarkus. Okay, now it's fine. So what I did is I just pressed backspace until I deleted the invisible weird character that got copied from Quarkus. So the text was fine. So that prints 20 and 12. So I will put a breakpoint here. I'll say A is equal to 12. I then step. So A is now 12. Now, if I go inside change A, so I press step into. So inside change A, right now, when I say A, it's still 12. That's this A from line 8. There is a quiz on Quarkus, which I'm currently solving. Go do it. So now I said A is equal to 20. And if I query what A is now, that is going to be 20. However, over here on line 9, so if I switch back to line 9, where Python is waiting for change A to finish running, here, if I say A, that is 12. Right? So there's two A's right now. So one is the scratch work inside change A, and one is the global A. Does that make sense? So inside of change A, so here it's over here, it's about to print. So inside of change A, I have the local variable A, which is equal to 20 and which is about to be printed. But once change A finishes running, there is only one A, and that is 12. So the 20 got printed, then we returned from change A, and now we're about to print the 12. So the answer is 20 and then 12. Make sense? All right. I did enable you know, like you can redo the quiz as many times as you like until it closes. Okay. So what about this one? So here what's going on is, again, the global A is equal to 12. And now we call change A, but change A now says global A. So that means when I change the value of A inside of change A, I change the global A. Makes sense? There is no other difference. So this, of course, would print 20 because I just said A is equal to 20. But here, when I print A, what gets printed is 20 again. So the answer is 2020. Make sense? So again, kind of, and I think when you see kind of that there's like all of those choices, I think the instinct for many people is to try to eyeball it. That probably would not work, especially if you're new to this, right? So what you want to say is just like line by line, you know, A is 12. Okay, is A local or global? It's global because not inside any function. Change A, what does change A do? So does it have a side effect? Yes, it does look like it has a side effect because this is one of those patterns that we saw where the job of the function is to change the value of a global variable. So that's the pattern you see, global A equals 20. The job is to change the value of a global variable, similarly to what you had in the lab this week with add and multiply and divide. The job of the function is also to print, right? So then you say, okay, so what does change A do? Just line by line, it says global A equals 20. So that means change the value of a global variable. And then it also prints 20 because what else would it be? You just said A equals 20 and then you said print. Okay. Questions? All right. So that was the quiz. So I am looking at people's answers. So I think so far, again, I think people said it's all fine, or at least kind of it's mostly fine for most people. I also wanted to show you this distribution because a lot of the time people come to me and say, I have no experience and all my friends have a lot of programming experience and I feel like I'm behind. So this is just to show you that, you know, you can, there are all sorts of people with all sorts of levels of experience. I really am trying to make it so that the class is interesting for everyone, and also so that people who are just starting out are kind of at the center right now. Okay, and so you know there are 10% of people for whom it is too fast and they have no experience, which I'm a little bit worried about. So I do have the lab catch-up sessions on Thursdays at 6. They're not super well attended. So I don't think there is like any time other than 6 o'clock when we can do those. But they're also broadcast on YouTube. So the YouTube recordings are posted on the front page of the course webpage. So check that out. Maybe come to the session if you can. I understand that 6 p.m. is kind of late. So project 1 is now posted. So it's worth 10%. It's due at 3 o'clock on September 29th. That's the Sunday before the first test on Monday, I suppose. So I kind of pushed it forward as much as I could. I felt that, like the timeline is a little bit compressed, but at the same time, your tests start, I believe the day after September 29th. So if I were to make the project be due after that, what would happen is the tests would occupy people. So it's going to be, I believe, one of your courses uses Gradescope as well. So I will make Gradescope available, hopefully today, but if not, then over the weekend. You can work by yourself or you can work with a partner. So grading is not affected, people sometimes ask, by whether it's one or two people who submit. We, in fact, just look at your submissions and we see how many test cases the program passes. So test cases means, a particular input is given to one of the functions, and we check whether the output is what we expect or not. So when you submit on Gradescope, you will see the outputs for several of the public test cases. So those will also be, visible. So if your program passes none of those, it's likely that there is a syntax error or something like that. And because we're grading you on how many test cases you pass, if you're passing none of the public test cases, that probably means that there is a big problem, and it probably will not pass any of our secret cases either. And usually it's, a simple fix to do something so that there's not just a global syntax error where you, for example, missed a semicolon, missed a colon in your code or something, okay? Because it's based on the number of test cases that it passes, it's really important that it passes at least some of the public test cases, ideally all of them. All right. So we'll look at project 1 later today. So I should say at this point, it is kind of a little bit jokey. I could not really change it. So obviously kind of we've all heard the kind of sad news for the division. I'm not going to tell you the fire joke or anything today, trying to kind of keep things, just like out of respect. But yeah, I apologize. I could not change project 1, that it is what it is. So I will tell you the pirate joke on Monday or something. So as far as kind of advice, again, we'll look at project 1 in more detail momentarily. So the biggest thing is start early, right? So getting things to work usually takes more time than you plan to. And that's the case with everything in life, but especially so with programming, where it's very brittle, right? So like if there is like one thing that's wrong somewhere, this might break the entire thing. And until you fix it, it's possible that nothing works, right? So again, kind of break things down, make incremental progress. So ask yourself, like, what's the smallest amount of progress that I can make? Then write that 1 or 2 lines, test it, and then iterate. So if you're stuck and you're just like staring at your screen, you don't know what to do. So ask yourself, what is the expected input? What is the expected output? Write down the examples. That a lot of the time makes things a little bit clearer. So test thoroughly. We'll discuss testing in a second as well. So lab 2 and the example from today should also help a lot in terms of understanding what's going on. So if you did not completely understand lab 2, what I would suggest is watch the session from yesterday at 6. So that's posted on the front page of the course. So before I get into project 1, I want to do just a few kind of odds and ends things which don't necessarily fit into the narrative. So one is what's called doc strings. So before I do doc strings, I'll do multi-line strings in Python. So in Python, you can have a string like that contains multiple lines. It needs to be enclosed in triple quotes. If you try to do it in double quotes or single quotes, it will just give you a syntax error. And that's a regular, a regular string. So I can say like A is like, something like this. And then if I print A, it will just print the multi-line string. All right. So you can use, and if you try double quotes, that would just say that doesn't work. So ISO inserts the second quote automatically, but here, like I pressed enter and it already was not happy. If I do it in the program, it would also just say, doesn't make sense. So one way to use it is to do doc strings. So here's an example. So this is just the doc string without the body of the function, which we could also fill in. So you can think of it as a comment. It is technically not a comment, it is a string. And it can work like that. So by convention, you say what the function is supposed to do in the imperative. So this is in English, technically it's called the imperative mood, right? So you say like return the sum of the numbers in B in the sense of like do that. Okay. And that's just the convention. That's how people write doc strings. Of course, you don't even have to write them in English, right? And then you can, list the parameters or something. The reason we do it is just to make things clearer for the person who's reading the code, which might be you from the future, who would be thankful that you would do it, for your future self, or it could be your partner who is also working on the code, or if you're working on a large project, of course, someone who takes over the project or people from other teams and so on. All right. So this is kind of like an advanced thing that you don't have to understand right now, but just as a note, there is a difference between doing a comment, which you certainly can also do, and doing a doc string like this. And the difference is, so again, just kind of to tell you. So for example, I can say help F, and it would know, well, maybe it's not obvious to you that this is a doc string, but like doc string 1, 2, 3, I run it again. I can say, help F, and it will display the doc string. So Python will just ignore anything that comes after the pound sign. So that would definitely not be able to work because Python just ignores everything that comes out after the pound sign. The doc string Python actually reads in, and you can retrieve it, for example, using help of F, where F is the name of the function. Again, this is just like optional advanced material, but it's an actual thing in Python as opposed to just something that Python ignores, right? So and it's worth pointing out, again, this is kind of a more advanced thing, but it's worth pointing out that like what is this really like? So this is kind of like saying 42 or saying hello just in the code. So this is not instructions to print 42 and hello. Those are just, the value 42, I put it here. The value hello, I put it here. So in the same way, I've put here the value docstring 123. So this is how Python thinks about those things, is as values that you put in your code that are actually read in, but for which there is no instruction to print out. Make sense? Yeah. Well, you cannot really you cannot really use it if you don't store it anywhere, right? So that's kind of a wrinkle. So there is kind of like, again, kind of just as a preview. So if you mention the same value multiple times in the program, Python might try to just store that value once, but we'll talk about it way, way later. Okay. Other questions? All right. Okay. I think there was something on Discord. Oh, okay. I already had Discord. So I did hire Gustavo, and then the rules changed. So we are not hiring second years anymore. We used to be able to do that. So okay. So programs for sharing code. What happened with Gustavo is he got hired as a TA. So sharing code, let's defer this. So the answer is basically, I would, if you don't want to use something like GitHub, then what I would suggest is just some kind of file sharing thing, like like the Windows share files thing, or something like that. And the reason is like it's like I think it's easier to do things that way, but let me get back to you on that. So, okay. So the other thing I wanted to do was control flow with return. So control flow is a technical term. It just means the order in which the lines are executed, or the way in which I control which lines are executed. So the return in Python, once you execute something like return2, that is the last thing that happens in the function. So it's not necessarily the case that all the return statements you will get to. If one is inside an if statement, you will not. But in this particular case, for example, when you say return2, and this is unconditional, this will always happen, print high will never be executed, return3 will never be executed. Okay, and that's just because the first return that you hit, that's the end of it. So let's do just the same example as what's in the slides. So I say, return2, and then I say print high, and then I say return3. And in my main block, I'll say A is equal to F, and then I will say print A. So I'm putting a breakpoint here. So again, what's going to happen is the value of F is going to be just 2. And the reason is I step into the function, and the first return that I hit, which is return2, that's the end of it. So if I press next, I'm returning, and the value 2 is going to be assigned to A. So I never got to line 3, definitely not to line 4. Okay, so this is not literally the first return textually, right? So if I say something like if false, return2, well, that's never going to be executed, because if false is never going to be a condition that holds, right? So let me run it again. So we step in, and here it says if false. So you skip over line 3, and now you're on line 4, and now you're at return 3, and now the value of F is going to be just 3. Okay. Make sense? Questions about this? Okay, so let's do an example with a calculator. So let's say that I want to do something like this. So I'll say like arg1, and I'll say arg2, and I say operation. And I'll say return arg1 operation arg2. And the parameters are arg1 and arg2. So this is just like a way of writing things. You don't have to follow this format, right? So those are numbers. And then op is plus or minus or times or divide. And that's just a string, so those would be in quotes. So how can I do it? So what I need to do is I need to check what op is, and then depending on what op is, I will do different things, right? So I'll say if op is equal to plus, I'll return arg1 plus arg2. And then if op is equal to minus, I'll return minus. And then if op is equal to times, I'll return times. And then here I'll do division. Make sense? So I'll actually do an ls. Okay, so now here there is no question of what's going on because we already had lots of examples where only one thing happens out of the if, elif, elif, elif thing, right? I can, however, do something like this. So what's going to happen here? So if I just do calculator, 6, 7 plus, that will print whatever, 6 plus 7. So the idea here, though, is that if I do something like caret as the input, what's going to happen is operation not recognized, right? So why is that? So if I put a breakpoint here, so I'll step in, and what's going to happen is it's going to check, is it plus, is it minus, is it times, is it divide? No, it's none of those. So none of the returns happened, and now we are on line 16. So on line 16, we're returning operation not recognized. So this return is not inside the if statement. It's just that it's the next thing that's after the if statement. And if you get to it, then that's what gets returned. So that is kind of one way of having like a default thing that gets returned if none of the returns up above it happened. Yes. So yes, it would be. Yeah. Yes. Yes. Yeah. Sorry, I can't really hear you. You mentioned it plus the operation. Yeah. So right. So that's a great question. So the question was, if I put in a plus here, why not operation not recognized? And the reason is if I step in, then here op is equal to plus. So I'm returning arg1 plus arg2. And again, the first time that you have a return statement, that's the return value. Right? So that's one thing you can do is you can have kind of a default, and I put it in quotes, if nothing else got returned by that point. So the other thing that you can do is kind of the other way. So I'm copying and pasting this into a new file. So I can say before I do anything, so this is going to be kind of a check of, is there a special situation? So for example, I can say if op is division and arg2 is 0, then I can say division by 0 error. And then because I've already returned division by 0 error as the special case up top, I don't have to worry about arg2 being 0 over here. Does that make sense? Because if it were the case that op is divide and arg2 is 0, I've already returned on line 9. So this can be used in order to kind of check something quickly where you don't want to worry about it later. Is that making sense? Questions? All right. Okay. So one last thing, and then I'll do a quick kind of project one example kind of thing. So integer division. So ordinarily the forward slash sign. So if you don't know, so like the divide is forward slash, the other way is backslash. So forward slash means divide. And ordinarily, it just gives you a float as an answer. So for example, 15 divided by 2, 7.5. So you can use two forward slashes to mean integer division. So for positive integers, this would be just rounding down if need be, right? So if you remember, there is a thing called the remainder. How many people remember what the remainder is? Not everyone. Okay, quick review of grade 5. So if you're just thinking about positive numbers, right? So for example, 15 is equal to 2 times 7 and then plus a little bit. So that means that 15 divided by 2 is equal to 7, because 15 is 2 times 7 plus a little bit. And then the little bit is the remainder. Make sense? Yeah. So it's in neither. So for positive integers, it rounds down, so drop. However, if you get into negatives, it's a little bit more complicated than that. You can think about it as round down, but really you shouldn't be thinking about it like that at all. So if you know what you want for the negative division, you should just explicitly say. Okay. And so anyway, so the remainder is so again, like think about 15 divided by 7 equals 2. So that means that 15 is 2 times 7 plus the little bit. The little bit is the remainder. Okay. Okay, questions about this? All right. So I will usually, we'll use it in the course a little bit. Like the reason I mention it now is because you could use it in project one, you don't have to. I will usually say mod, so short for modulus. So like in programming, we say mod. Yeah. So 15% sine 2 is 1. Yeah, so that's the remainder of the division of 15 by 2. Okay. All right, so let me now introduce project one. So it's a quite lengthy handout. A lot of it is kind of, it's important stuff, but it's kind of boilerplate. So read it, but once. And then this is the description of the project. So basically what you're doing here is you are simulating what would happen if you were to do something like a Fitbit that gives you points. So I bought a Fitbit, I think like, last spring. So not this one, the one before. I got really addicted to it. I get really annoyed if I wake up and it doesn't detect the fact that I woken up, because then my resting heart rate gets counted as higher than it really is. And then I lose like fitness points. So anyway, it's very aggravating. So this is what we're simulating. And so you are writing all those functions. So the way the functions are supposed to work is you should be able to say something like perform activity, and then you say which activity you're performing and for how long. And then we have two things that you're keeping track of. So one is health points, and there are rules which you encode with if statements and stuff like that, according to which health points get awarded for the different activities. The activities are running, resting, and carrying textbooks. And then we have kind of, so I call them hedons. So hedons is like a term that people sometimes use in economics. 4 kind of fun points. So this is from kind of hedonic enjoyment. That's kind of the philosophical term. So hedons are kind of made up points that there are rules about how you calculate them. And, from running for 30 minutes, you get minus 20, 30 minutes, you get minus 20 hedons according to the formula that I made up based on my personal experience. So there is rules about how you compute all of that. And then we can ask, what is the current amount of hedons? What is the current amount of health points? We could also ask what is the most fun activity that you could do in the next minute, which would be what is the activity out of the 3 possible activities that would give you, for the next minute, the most fun points. There are rules about how those are calculated, so it's going to be different depending on the situation. Okay, so what else is going on here? So so there's also you can also offer a star. So like if you are offered like a star for a particular activity, then the amount of hedons that you get out of that activity changes because stars like make you enjoy things more. Okay, so that's the idea. All right. So there are rules which you just basically encode with math and if statements. That's everything that you need. So what I want to do now is I want to do a small example that's like project 1, but simpler. Okay, so here's the example. So let's say that I want for jumping to give you 1 hedon per minute. And then unless there was a non-rest activity less than an hour ago. And then swimming gives you 2 hedons per minute. And what I want to keep track of is how many hedons do you have. So let me first write a simulation here. And again, kind of if you're confused about like what is the simulation exactly, that is natural. So the answer to your question is the simulation is like what I'm writing here. Your job is to look at the example over here and just make the functions work so that the output is what it says here. Of course, kind of make up your own examples as well. So, okay. So I'm starting the simulation. So I'm going to say perform activity jumping 20, and then I'll perform resting for 30. And then I'll do swimming twice, I guess. So something like this. And here, I just want to follow so this is jumping for 20 minutes. And what I want to do is I want to just keep track of what the hedons are supposed to be here. So according to those rules, jumping gives you 1 hedon per minute. So this is plus 20. So resting is nothing. Oh, I said resting twice. Okay. So this is going to be plus 20 again, because this is plus 2 times 10. And then this is plus 0. Does that make sense? So I just have this scheme of jumping gives me 20 per minute, and I do it for 20 minutes. So this is plus 20. And then swimming plus 2 times 10, right? And then for jumping, there is a special rule, which we'll implement later, where if there was a non-rest activity less than an hour ago, then it gives you 0. So, okay. So this should remind you of the example that we just did with the calculator plus the calculator from this week's lab, right? So essentially, the only way to communicate to perform activity is via a global variable. So we'll just have a global variable. We'll call it hedons. which initially is going to be 0, and then perform activity is going to update that. So I'll define perform activity. And I'll say, okay, I need to modify hidden. And for now, I'll just encode the rule for jumping and for swimming. So I'll say if activity is equal to jumping, then hidden is going to be hidden plus minutes, because 1 per. So I'll do ×1 to be nice about it. If activity is swimming, I'll do hidden plus minutes ×2. So I can be even nicer about it and kind of factor the 1 and 2 out, right? So I can say, let me not do it right now, actually, sorry. Running out of time. Make sense? So now I could print hidden. And that would give me this 20 plus this 20. So there's one more rule. So the way you imagine things going is like this is the first 20 minutes, and then this is the next 30, and then the next 10, and the next 15, and so on. And I want for it to be the case that if there was a non-rest activity less than an hour before the jumping session, that I do not accrue hidden. So how can I do it? Well, what I need to do is I need to know what the last activity was, right? So that's, again, the same as the calculator example from the lab, where I need to have another variable that remembers what the last activity was. So I'll set last activity to resting initially. And then here I'll say, so if activity is jumping and last activity is resting, then I increment the hidden. So that also means that I need to update last activity every time. So after I'm done, so I've checked, is activity equal jumping? Was last activity resting? Now I can say, okay, last activity is now just activity. Because last activity is a global variable, so it exists outside the function as well, I need to also say global last activity. Make sense? Are there questions? Yes. Because I said less than an hour ago. Okay, sorry. So for today, you're right. I forgot about less than an hour ago. Thank you very much about that. Fixed it. Okay, so we'll do the more expanded example next time. Thank you. So that's not very much a favor to you, because so I will post the solutions to the original problem like in about an hour when I get to my office. If you want to look at it right now, I will also do it on Monday. So the long and short of it is that you also have to have a variable that keeps track of how many minutes have elapsed since the last activity. Okay, so that is basically project 1, except less elaborate. So what I would suggest is like, get started this weekend because there is no other time. Make sure that you can reproduce this example. If you can reproduce this example and you understand lab 2, you should be pretty much fine for the project. Yes. Yeah, so anything that so if Gradescope tells you that the submission is fine, the submission is fine. And you can use whatever you want in Python. But Gradescope will check. Okay? Yeah. Yeah, the one person, so there will be instruction, one person submits and then adds the other person to the team. Okay? All right, thank you very much. Have a good weekend. Bye. Right.